Okay, this is the first demonstration for intro to light. First, you just shine a flashlight on things and talk about what you're seeing, which is no big deal. Then you take that laser pointer, aim it at something, and then you have to just poof the talcum powder in the beam of light. There you go. Okay, the first exploration, each child will get a baggie, or I'm sorry, each group will get a baggie containing a piece of black paper, a clear acrylic block, and a piece of quartz, as well as a flashlight. Before the class starts, you're going to want to put the batteries in the flashlight. So you just put the positive end, each battery one takes 3 AAAs, the positive end goes away from the spring, the negative end goes against the spring, and then you put it in so the bump or the positive end goes down into the flashlight, and screw this back on. It's just the button part screws, and then they just shine. They're going to shine the light through the materials, and so they'll see that this is transparent, this is translucent, and this is opaque. Okay, so for the second exploration, you need to have the incandescent bulbs screwed into the lamp bases, and I might as well show you how to set up the LED bulbs as well. All of the bulbs need to screw into an adapter, and then carefully screw it into the lamp base. Before class starts, you're going to want to make sure each bulb is set to the right color of light. All the lamp bases have a switch on the base. To set the color of light, you want one to be red, one to be green, one to be blue. It looks better in person than on the video. And to change the colors, you use this remote, and just make sure that only the one that you're changing is turned on, or they will all change. So you'll have that set up before class. Then for exploration 2, you're going to turn on the white light, the incandescent light, and the kids will look at it through the spectrometer. They look through the viewfinder on this side. Then there's a small horizontal slit here and a long vertical slit here. They need to look at the light through the small horizontal slit, make sure it fills that slit so that they see the spectrum. They can do that really from their seats because they can look at the ambient light in the room, the fluorescent light, all of the light in the room will give them a spectrum no matter what they look at. The brighter something is, the brighter the spectrum will be. And the goal is just for them to understand that white light is made of all the colors of light. Okay, for the third, for the elaboration activity, which is not the non-optional one, you're going to hold up one of this 8x10 pieces of black paper that has a red, green, and blue dots painted on it, and ask, without the students looking through their filters, ask them to predict what they will see when they look through the filters. After they've predicted what they see, every student gets their own laminated paper with red, green, blue, and white, and then they can look through them with the filters. The white is to compare what it would look like if they were looking at all the light, basically. If you have time, you can also do it with the white paper and the white dots. Basically, when you look through at the black paper, like with the red filter, the other colors, the blue and the green, the white dot looks red, and the blue and the green disappear because there's no red in them. Versus if you look at the white paper, the blue and the green just look black, so they match the black dot. Okay, if you have time for the final elaboration activity, the optional one, you need to reset the lights to be orange, teal, and fuchsia. This is red, green, and blue are the first colors to choose, and the orange, teal, and then fuchsia is down here at the bottom. So you turn it on and change it, and then turn the second one on and change it, and turn the third one on and change it. And then the students are going to look at the LEDs with their spectrometers, and they'll see just 2 bands of color, like when you look at the orange, you see just red and green bands. When you look at the teal, you see green and blue bands. And at the fuchsia, you see red and blue bands. So they'll want to write down the bands that they see and then predict what they will see when they look at them through the filters. This activity they will not be able to do from their seats because it's important that the light bulb completely fill the slit. So you'll have to bring them up in groups so that they can look at the light bulb just with the slit. And if they're at their seats and they see the light bulb, but then they see a lot of the ambient light, they'll see the spectrum of light from the rest of the room. And so it is important that they fill the field with the light bulb. And that's it.